Hello everyone, welcome to my channel Chem Insider. In today's video, we are going to discuss about ionic or electrovalent bond. In the previous video, we learned about covalent bond and how is it going to form between two atoms of a molecule. It may be similar or it may be different. So, what happens in covalent bonds are, two atoms usually share electrons between them mutually in order to obtain their respective octet structure. But in order to explain certain composition of elements such as beryllium, boron, lithium, etc., which had less than 4 valence electron, octet rule was not sufficient enough to explain the structure of those elements in case of beryllium chloride or lithium chloride or boron trifluoride. Therefore, now we have to learn about new type of bond called ionic or electrovalent bond. We all know about this ionic or electrovalent bond. This was proposed by Koshal and Lewis, right? In the first video itself, we discussed about Koshal and Lewis theory of formation of ionic or electrovalent bond. So there they just said it should be an electrovalent bond. They didn't explain the ionic bond formation, but Koshal explained the electrovalent nature, Lewis explained the ionic nature. That is, if you consider for a neutral atom, it has to either lose electron or it has to gain electron in order to involve in a bond formation. That was what Lewis said. And Koshal said that two atoms will be having an intermolecular force of attraction, which is an electrostatic type of force, and that type of force result in a bond formation, and that bond is called as electrovalent bond. So now, in this video, what we are going to know about is, we are going to combine both these two theories in a simple manner and learn about the bond formation. So what happens here is, for an element or a molecule to form electrovalent bond, or in order to form any chemical bond, it has to follow two particular instances. One, it has to gain an electron to form a negative charge, and has to lose an electron to form a positive charge. That means it should form a positive ion and it should form a negative ion, cation and anion respectively. And the extent of that particular elements which are converted to ions are to be arranged in a three-dimensional solid structure, which is called the crystal lattice, as we have written over here. So this is a crystal lattice of a compound, and we are to arrange those cations and anions in the respective arrangement in 3 dimensions. So, if an ionic bond has to happen, first it has to follow two criteria. One is a neutral gaseous atom has to be converted to cation and it has to be converted to anion. A neutral gaseous atom, one has to be converted to cation and the other has to be converted to anion, so that those two ions can be arranged in a crystal lattice to form a solid crystal. Okay. So now, if I say what is the formation of cation and anion is, let us say if we consider a metal which is losing an electron to form M plus, N plus, let us say n number of electrons has been lost, it forms Ne minus number of electrons. Now, an element which gains those number of electrons, let us say Ne minus, and forms Xn minus. And in overall reaction, what are we going to say here is, M and X, Ne being it cancelled, clearly combines to form Mx. So here, if we observe this reaction of half reactions of these two elements, metal has to lose electron, something which we have read earlier, right, in the previous chapter. If a metal has to lose electron, that means it is nothing but the ionization enthalpy which comes into play. If a metal has a very low ionization enthalpy, it can lose electron easily. Next, if a metal has to gain electron, there we come across a concept called electron gain enthalpy, right? Electron gain enthalpy. So, for an ionic molecule to be formed with ionic bond, there involves two energy sources. One is ionization enthalpy and the other one is electron gain enthalpy. Metal has to have low ionization enthalpy, and other elements should be having very low negative value, very high negative of electron gain enthalpy. And further, what we know is ionization enthalpy is always endothermic reaction. Ionization enthalpy is always an endothermic reaction, whereas electron gain enthalpy sometimes will be exo and sometimes it will be endo. It will be both exo and endothermic reaction depending upon the electrons which you are adding. So what we are going to observe over here is, if an ionic compound has to be formed in case of ionic or electrovalent bond, there will be involvement of ionization enthalpy and electron gain enthalpy. So this is all about how an ionic bond or electrovalent bond is formed. Now, what is the criteria to form an ionic bond or electrovalent bond in a simple manner? For a molecule to form an ionic bond with very much ease, it has to have a very low ionization enthalpy, and the other element, it should have very high negative value of electron gain enthalpy. That means it should have a very low ionization enthalpy value and a very high negative electron gain enthalpy. And we clearly know which two elements have that type of possibility. That is, one with a very low ionization enthalpy, those are nothing but the elements which are present on the left hand side of the periodic table, right? The elements which are present on the extreme left of the periodic table have a very low ionization enthalpy, and the elements which are present on the extreme right of the periodic table have very high negative value of electron gain enthalpy. So clearly what we can say is, metals usually form cations, metals form cations, and non-metals form anions in an ionic compound. Metals which have low ionization energy, which have low ionization enthalpy, form cations in this case, and non-metals which have very high negative value of electron gain enthalpy form anions by gaining electron. Along with this, as I said here, electron gain enthalpy is certain times of exothermic reaction and at certain times it will be an endothermic reaction. So what happens here is, when electron gain enthalpy is endothermic reaction, there will be a negative charge energy, negative change in energy, which will be accompanied for an endothermic electron gain enthalpy, and that particular energy is called electron affinity. So what is this electron affinity is? Electron affinity is the negative energy change. Electron affinity is the negative energy change which is accompanying the endothermic electron gain enthalpy. So now this is all about the ionic bond formation and the criteria which are required to form the ionic bonds in an electrovalent molecule of the first point. Because as a first point we discussed said that for an ionic bond to be forming, first point is it has to form a positive and negative ion from its respective neutral gaseous atom. So in order to form its neutral cation from a gaseous atom, in order to form a cation from its neutral gaseous atom, it has to involve ionization enthalpy, and we have formed that which ions usually form the cations, that is the metals which have the low ionization enthalpy. And for it to form a negative ion from a neutral atom, it should have very high negative value of electron gain enthalpy, and we also know which elements do thus, that is non-metals which have a very high value of negative value of electron gain enthalpy. So we have completely cleared off the first criteria. Now for the second criteria, what we have discussed is it should be arranged, the cations and the anions are to be arranged in the three-dimensional solid structure, which on crystallizes in a different certain manner, which depends upon the packing of those electrons and cations. Packing of those anions and cations result in the geometry or the crystalline structure of the given ionic compound. I hope you are getting this. If you consider for an ionic compound to be formed, there are two criteria. One is it should form a cation and anion respectively from its neutral atom. That is what we have discussed over here. And for the second point, what we have said was it should arrange themselves. The anions and cations are to be arranged in a crystal solid in such a way that when it is being crystallized, it should form a particular crystal lattice. Lattice is nothing but a skeletal structure. Okay, so whenever you build a house, what they do is they first put up the pillars, right? So they can clearly have a skeletal idea of the given house to be built. Similarly, whenever you arrange cations and anions, it has to be arranged in a specific manner of skeletal lattice structure, and then they have to be arranged in specific positions in the three-dimensional space. So the second point of arrangement of these elements, that is anions and cations, in the three-dimensional space involves a new type of enthalpy called the lattice enthalpy. So what is lattice enthalpy then? In order to directly go to the lattice enthalpy, let us consider the first process and then we'll relate that with the second criteria. Whenever an atom has to be arranged, whenever ions like cations and anions have to be arranged in a given cubical structure, Lewis said those elements or ions, that is the valence electron present in them, should be arranged in a cubical manner, right? So now instead of taking the electrons being arranged in the cubical manner, let us consider cations and anions being arranged in the cubical manner. Now, for that to happen, if you consider for the sodium atom in the sodium chloride compound, okay, the structure which I have drawn over here is a lattice structure where orange color denotes the sodium atom, white denotes the chlorine atom. So this is how we are going to arrange sodium chloride, and several other element compounds like zinc sulfide or cesium chloride will have a different type of geometry. That is because of its packing arrangement. Here one sodium will be attached with one chlorine, and these two are mutually shared between two sodium atoms. So therefore these have a different type of geometry, and several different have different types of geometry. That is because of the complete dependence on packing arrangement of cations and anions. Now we will just consider a simple crystal lattice where sodium atoms and chlorine atoms are arranged. Okay, so now if you consider for the formation of sodium chloride, it involves sodium being ionized to Na plus with a loss of electron. Okay, Na plus with a loss of electron. The ionization enthalpy of this reaction, the delta H of ionization enthalpy of this reaction is found to be 498.5 kilojoules per mole. The energy required to ionize sodium to its respective sodium ion is 498.5 kilojoules per mole, because as we know endothermic reaction, ionization enthalpy is an endothermic reaction, there will be positive sign of the delta H. Next, for chlorine to gain that electron from sodium and forming NaCl minus, it requires electron gain enthalpy delta Eg of H, which is found to be minus 340 kilojoules per mole. Minus 340 kilojoules per mole. If you combine these two, that is Na plus Cl gives us NaCl. Na plus Cl gives us NaCl. The sum of these two reactions will yield us delta H being equal to 150 kilojoules per mole. Okay, let us say approximate 150 kilojoules per mole. Okay, so whenever you combine sodium with chlorine, we should come across an energy, liberation of energy for about 150 kilojoules per mole. That means 150 kilojoules per mole of energy should be absorbed by the sodium and chlorine atom when they are forming sodium chloride. But what happens in this case is, instead of absorbing the energy, we observe that delta H was being minus 788 kilojoule per mole. So observe over here, we have a positive sign in the case of this delta H calculated experimentally, and the delta H was found in the experiment theoretically. This is delta H calculated theoretically, which is 150 kilojoules per mole, and the delta H which was found out in the experiment was minus 788 kilojoule per mole. So clearly there is a overcompensation because of this 150 formed by theoretical data and minus 788 formed by the experimental data. So this 150 is nothing but the absorbed energy. 150 kilojoules is the energy liberated. 150 kilojoules is the energy liberated, and absorbed energy is minus 788. So if you consider these two relation, what we can say is there is a completely change in energy which was supposed to be experienced by the sodium chloride atom when sodium and chlorine has to be formed. So what we say is, whenever you consider for the formation of molecule of ions, that is the ionic compound, by cation and anion, then we come across with certain elementary alteration in case of energy changes. That particular energy is called the lattice enthalpy. So what is lattice enthalpy in particular definition? So what do you mean by lattice enthalpy is, it is the energy required. Lattice enthalpy means it is the energy required to break 1 mole of a given ionic compound into its respective gaseous ions. Like if you consider sodium chloride itself, what happens here is, when you break sodium and chlorine, the sodium chloride atom, it requires certain amount of energy. Now, if you consider 1 mole of sodium chloride, it requires 788 kilojoule. It requires 788 kilojoules of energy in order to break down to its respective Na plus and Cl minus, and making sure those are as far as apart from each other. So the actual definition of lattice enthalpy is the energy required to break an ionic compound into its gaseous ionic forms and separate them to a infinite distance. So energy required to break an ionic compound to its respective gaseous ions and separate them to an infinite distance. Okay, so that energy which was used for this particular process of separating these two ions to an infinite distance is called lattice enthalpy. So lattice enthalpy is the energy required to separate an ions from its neutral ionic compound and making sure those two are as far as apart from each other. So this is what we call the lattice enthalpy. So in general, if you have to state it in a simple way, it is the energy required to break the bond between an ionic compound of 1 mole. The energy required to break bonds of 1 mole of an ionic compound and separate its respective gaseous ion components from an infinite distance. That is what lattice enthalpy says. So lattice enthalpy is used inside it is kilojoule per mole. If you are using for per mole, that will be kilojoule per mole. Or if you have to separate sodium and chlorine from sodium chloride compound of 1 mole, you must use 788 kilojoules per mole of energy. Okay, so this is all about lattice enthalpy. I hope you have understood about the ionic or electrovalent bond and the lattice enthalpy. As I said, ionic bond formation involves 2 important criteria. One, it should form positive and negative ions from its neutral atom, and second, it should be following the lattice enthalpy in order to overcompensate its lattice structure in the 3-dimensional arrangement of cations and anions, giving their respective crystal lattice. Okay. If you have understood this video, please do subscribe to my channel and share this video among your friends so that they get use of these videos, and I'm going to post more videos of these chapters in the next coming days. Thank you for watching.